Hello, my name is Mama Akil bin Zulkarnain. For today, I will be showing my additional task question. For the additional task, here is the question that I have chosen. The first question is about recurrence relation, where given an equals to 8 times an minus 1 plus 9 times an minus 2 for n bigger than equals to 2 if a2 equals to 83 and if a3 equals to 727, find the value for a0 and a1. For the question B is about mathematical induction. Use the principle of mathematical induction to prove the following statement is true for all positive integers n. The following statement is the summation from I equals to 1 until n, I times 2 power of I equals to 2 plus n bracket n minus 1 bracket 2 times 2 power of n plus 1. Here is the working step for question A. As mentioned in the question, n bigger than equals to 2. So we change the value n to 2 and we will get a2 equals to 8 times a2 minus 1 plus 9 times a2 minus 2, and it will be 83 equals to 8 times a1 plus 9 times a0. So we still don't have the value for a1 and a0. But remember that n is bigger than equals to 2. So let n equals to 3 and we will get a3 equals to 8 times a3 minus 1 plus 9 times a3 minus 2. It will be 727 equals to 8 times a2 plus 9 times a1. This way, we can calculate for a1 since we already have the value for a2, which is 83. So a1 will be 7. Now we replace a1 value on the previous equation that we cannot calculate earlier, and it will be 83 equals to 8 times 7 plus 9 times a0. Now we can find the value for a0, which is 3. So the final value is a1 is 7 and a0 is 3. Here is the working step for question B. For mathematical induction, there is four steps we need to remember. The first one, we need to show the first element is true. The second one, we need to assume that pk is true. For the third one, we need to show that pk plus 1 is true. And the fourth step is the conclusion. Before we move to the steps, first we need to let the proposition as Pn, which will turn the following statement into Pn equals to summation from I equals to 1 until n, I times 2 power of I equals to 2 plus bracket n minus 1 bracket 2 power of n plus 1. So for the first step, we need to show the first element is true by change the n value into 1. So it will be true, as you can see here. It becomes 2 equals to 2, which is the same value. If it's not the same value, then it is not true. Then for the second step, we need to just assume it is true. So we change n to k, and it will be like this: pk equals to summation from I equals to 1 until k, I times 2 power of I equals to 2 plus bracket k minus 1 bracket 2 power of k plus 1 is true. Step 3 show that pk plus 1 is true. So we need to substitute the value n into k plus 1. So it will be pk plus 1 equals to the summation from I equals to 1 until k plus 1. I times 2 power of I equals to 2 plus bracket k plus 1 minus 1 bracket times 2 power of k plus 1 plus 1. For the right hand side, all we need to do is just subtraction and plus, and we will get the final answer, which is 2 plus k times 2 power of k plus 2. For the left hand side, as we all know, for the summation, the summation k plus 1 also include the summation of k. So it will be 2 plus bracket k minus 1 bracket times 2 power of k plus 1 plus k1 plus k plus 1 times 2 power of k plus 1. For this, we need to extract the 2 power of k plus 1 And we will also get the same final answer from RH from the right hand side, which is 2 plus k times 2 power of k plus 2. Since our left hand side and right hand side are similar, it means that our conclusion is true. So we need to write therefore by using mathematical induction method, the proposition summation from I equals to 1 until n, I times 2 power of I equals to 2 plus bracket n minus 1 bracket times 2 power of n plus 1 is true. That is all for the additional task. Thank you for watching.